tasks in the task planning exercise. Now we'll focus on task 4 today. Now in this task, calcium burns in air to form calcium oxide, and you're given the information that the reaction is vigorous, and as a result, some of this calcium oxide can be lost as smoke. Now your task is to plan the investigation to find out the maximum mass of oxygen that combines to form calcium oxide when a particular 2 gram sample of calcium granules are burnt in air. Now, after you have read this, you realize that immediately you are able to identify the aim of this particular task. And it is none other than the second paragraph there, where it says that you are supposed to find out the maximum mass of oxygen that combines to form your calcium oxide. Now, one other thing that is important will be the part about how the reaction is vigorous. And you're also told that some of this calcium oxide is lost as smoke. Now, this should provide you some kind of an indication that there has to be some precaution to be taken. And we'll look at this reaction first, okay, in the form of a chemical equation. Now, in this chemical equation, I hope you can see that the oxygen that combines with calcium will in its entirety, okay, will form the calcium oxide. Therefore, the mass of the oxygen that reacted with your calcium will be part of the mass of calcium oxide. All right, this is really inconsistent with all the mass in this equation. And since we were looking at how the reaction is so vigorous, okay, as well as the part that calcium oxide can be lost as smoke, okay, we have to use the appropriate laboratory apparatus. And in this case, I want to let you know the difference between a laboratory crucible as well as an evaporating dish. Now, you probably would be familiar with an evaporating dish, but a crucible looks something like this, and there is a lid that comes together with it. On the other hand, your evaporating dish does not have a lid, and it is probably familiar to you because you might have encountered uh, forming crystals of copper sulfate in an evaporating dish. Now, the crucible will allow the reaction to take place safely. At the same time, okay, it will prevent any kind of calcium oxide to be lost as smoke because of the presence of the lid. You'll be able to prevent the smoke from escaping in that sense. To summarize, okay, our aim is to determine the maximum mass of oxygen that can combine to form calcium oxide. The variables in this case, same thing. Okay, you have your IV, DV, as well as your CV. Okay, as listed there. Okay, your IV is your calcium granules. The mass of the oxygen that combine with your calcium will be the DV, and some controlled variables include the mass of calcium at the start, the type of crucible with the lid, as well as how long you have heated the whole setup. That these are some examples of possible controlled variables. Now, in terms of the steps that you can take, okay, these are some suggested steps. Okay, number one, now you can weigh approximately 2 grams of calcium granules. The thing is that calcium granules are quite hard to break into pieces, and they don't come in powdered form. Therefore, there might be a situation where you have slightly more or slightly less than 2 grams. Okay, it might not be possible to get exactly 2 grams of calcium granules. Of course, the usual way of measuring the mass should be undertaken. And as you heat this calcium granules, you should have the lid on because of the previous part where we talk about how the smoke can actually escape, which contains some of the calcium oxide. Now we have to occasionally lift the lid to allow the fresh air, which contains oxygen, to enter this crucible. This will allow the calcium that has not reacted with oxygen to further react with oxygen to form calcium oxide. If you do not lift the lid, there might be a possibility that the reaction is incomplete, whereby not all of the 2 grams of the calcium granules has reacted with oxygen. Now, subsequently, you should cool this crucible, you should cool the apparatus, you should cool the contents within the crucible and weigh the crucible, and you have to repeat this until you obtain a constant mass. The constant mass would be would show would rather it would mean that your reaction is complete. All of the calcium would have reacted with oxygen. Now, at this point in time, I want you to pause and to think about whether the mass that you get at the end, will it be greater or less than the mass at the beginning? Okay. What I'm asking you is to think about the final mass of the crucible and contents. Will it be greater, less, or equal to the initial mass of 2 grams? Now, once you have thought about it, you can continue playing this video. Now, I hope that you have thought of this question properly, and I hope that you have come to this conclusion that the mass at the end is greater than the mass at the beginning. Now, this is because the oxygen has combined with your calcium, and the calcium oxide is of a greater mass or MR as compared to your calcium. So it is a combination between your calcium and the oxygen. Therefore, the final mass has to be a larger value than that of the initial mass. And to find out the mass of oxygen that actually reacted, you just have to take the difference between the final mass and the initial mass, and that will give you an expression. For example, I wrote there y minus x grams. And this is really the result of your task. And based on that, you will be able to come up with a simple conclusion, which will look something like this. Okay, therefore, the maximum mass of your oxygen, in this case, okay, which combined with the calcium, will be an expression known as y minus x grams. And that's it. Okay, with task 4, you remember the aim as well as the variables, the procedure, the results, and the conclusion. Now, always look back on the actual question to see whether you have answered the question entirely. And in this case, the conclusion will help to, you have to ensure that the conclusion is aligned with what is given in the question. Okay, with that, I end this sharing.